Okay, section 5.3, always with conditional probability. Question number 65 on page 240. I wanted to work at least one problem. So here is one. Question 65. H is the event observing a number greater than 2 on a toss of a fair die. So already the wording of this problem is a little confusing, but you want to think, okay, here's a fair die. I could get 1, 2, 3, 4, 5, or 6. These are the outcomes I could get. And H is observing a number greater than 2. So all these things are considered H. Fine. All right, whatever. You don't care. Find the probability that H occurs at least once in 3 tosses. So this is where it gets tricky. Probability of H at least once. Let's see if I can write this. At least once is equal to 1 minus the probability of no H in 3 tosses. So this is just something you either have to accept or wrap your brain around. The probability of H, this is H at, not hat, at least once in 3 tosses, is equal to 1 minus the probability of no H's in 3 tosses. So you're thinking, I want H to happen, here's 3 tosses, I want H to happen at least once. Well, if it happens at least once, that probability is the opposite of it happening no times. So it's easier to calculate the probability of no H's than at least one, because at least one means H maybe happened the first time, maybe H happened twice, maybe H happened all 3 times. There's just too many combinations to look at, so it's easier to calculate the probability of no H's and then take 1 minus that. So the probability, we'll work this up here, probability of H is equal to 1, 2, 3, 4 out of 6. So the probability of no H's, so you could think of that as H complement, that little c, that means the complement is equal to 1 minus the probability of H, which is equal to 1 minus 4 out of 6, which is 2 out of 6. Or, wait for it, 1/3. All right, I'm running out of space. So the probability of at least 1 in 3 tosses is 1 minus the probability of no H in 3 tosses. Now, because this is rolling a die and they are independent, so that means probability of no H is really terrible, I should just say H complement, on the first toss times the probability of, I'm just going to keep doing it, no H on the second toss times the probability of no H on the third toss. Again, you could also write this as the probability of H complement times the probability of H complement on the second toss times the probability of H complement on the third toss. So because they are independent tosses, we multiply, it's and. So we multiply the probabilities together. No H and turns into a dot. No H and, you can think of and turns into a dot when they're independent. So this is 1 minus the probability of, that's a little c there, H complement, we just said that was 1/3. Remember over here? 1/3 times probability of H complement on the second toss, that's 1/3. Probability of H complement on the third toss, that's also 1/3. So in this case, that is 1 minus 1/3 to the 3, 1/27, I think, is what the book gives you. Or they might just say 1 minus 1/3 cubed as the answer. So again, that's at least 1 means 1 minus the probability of no H in all 3 tosses. So that's 1 minus, this is no H in all 3 tosses. So here's your answer. That one's tricky. It's a tricky one. I'll do another one with babies.